The overall goal of this model system is to mimic the geometry and breathing motion of the pulmonary acinus for studying acinar airflow patterns and airborne microparticle trajectories.
This method can help answer key questions in the field of acinar transport phenomena, such as the effects of gravity, drag, and diffusion on particle deposition outcomes. The main advantage of this technique is that experiments are done inside a 1-to-1 scale model rather than a scaled-up model. This allows for accurate observation of particle Brownian motion. The implications of this technique extend towards inhalation therapy because a better understanding of aerosolized drug deposition can be achieved.
To begin, use deep reactive ion etching of a silicon on insulator wafer to fabricate a master silicon wafer as described previously. Next, mix the PDMS and curing agent at a 10-to-1 weight ratio inside a clean small container. Degas the mixture in a desiccator under vacuum until all of the air bubbles are removed. Place the master wafer into a petri dish and pour the degassed PDMS mixture to a height of approximately 1 mm above the master wafer. Degas the poured PDMS once again for at least 40 minutes until all air bubbles are removed above the wafer and bubbles below the wafer are minimized. Make sure that the wafer is as close as possible to the bottom of the plate. If necessary, press the wafer gently to the bottom using 2 stirring sticks.